comparatively uplifted region. And in this depressed region, continuous rainfall has accumulated water, and that become ocean. So depressed region converted into ocean, and that I said that the uplifted region become continent. So actually I said that what has been found, there are the two types of magma generally, but three types are there. Two types of magma. Magma means molten rock within the earth's surface, and these two types of magma, if I say that this is, I said that one it is, I said granitic magma, another I said basaltic magma. Granitic magma is more content, is I said that silica content is higher, and basaltic magma I said that ferrous magnesium content is much higher than I said silica. And therefore its density is around, I said that 3 gram per centimeter cube, and then its density is around, I said that 2.7 gram per centimeter cube. So the density of granitic rock, when then it has been converted into rock, it has been found that its density is how much? In 1 centimeter cube 2.7 gram, and then I said that basaltic rock has density is around 3 gram. And therefore the geophysicist found that this depressed ocean region is made up of what is I said that heavier rock, and then uplifted region is made up of, I said that comparatively less denser rock. And then I said that it has been found that the ocean which has been depressed, it should be heavier, denser. Then the ocean which is heavier and denser, it is made up of basaltic rock, and continent is made up of granitic rock. Now, till now you will see the same process is there. I said that, so I said around 4600 million years ago that the earth came into existence and full of magma and magmatic eruptions, and through the magmatic eruptions high water vapor and sulfur oxides, nitrogen oxides, carbon oxides, hydrogen sulfides and other methane gases, some amount, little bit but very less, and several other gases was there in the atmosphere, and then with the help of water vapor the rainfall continues, but the slowly upper surface has been solidified, and then most of the heat has been absorbed within the remaining side. And I said that in 39 and then upper portion of the earth has been solidified, and after during the solidification इसीलिए कहा जाता है कि ocean has been formed how many years ago? 3900 million years ago or 3.9 billion years ago. So ये portion क्या हो गया? Depressed. This portion has been depressed, and comparatively other portion was uplifted, and this uplifted region is that is an I said 29%, and then the depressed region which is I said that 71%. And it has been found that the depressed region has been made up of, I said that basaltic rock, and then uplifted region is made up of granitic. Understood? So this way our ocean and continent came into existence. But if you see, like I said, atmospheric, थोड़ा सा आपको यहाँ जाने दे रही है, atmospheric origin through tectovolcanic activity. I said that, so from 3.9 billion years ago से लेकर around, I said that 1 billion years ago, if we'll see, there is a kind of azoic, again I said that it is in a kind of azoic era, eon better to say. And during that period, azoic मतलब जानते हैं कि there is no existence of animals and all. But after that, there is a coming of some kind of, I said that, some unicellular structure animals. And by reaching 600 million years, this kind of, there is a coming of zoic 600 million years आते आते क्या हो गया, zoic structure become prominent. Zoic structure become very much prominent, and then zoic structure did two things. They did, I said that, one I said that photosynthesis kind, and chemosynthesis. This photosynthesis and chemosynthesis, I said that I said that gases available in the atmosphere. Synthesized the gases of atmosphere, and we are able to get slowly and slowly, I said there is a 20 or 21% we got oxygen, nitrogen around 78%. So this is the way the volcanic eruption, which has given us lots of amount of what is the gases in the atmosphere, further it has been synthesized by some unicellular, and then slowly prominent multicellular organism started coming, and then they started synthesizing through the process of photosynthesis and chemosynthesis, and then our atmosphere came into existence. So the volcanic eruption is the cause of, I said that atmospheric origin, and which has been earlier trapped within the Earth's surface. So we have been able to see how do we have been able to get the atmosphere. तो कभी आएगा भी तो थोड़े से शब्दों में आएगा, then you can be able to define how do the what I said that tectovolcanic atmospheric origin. In the 5 marks if it comes, possibility is there, so you can be able to write like this. अभी भी chemosynthesis होता है. If you'll see in the mid-oceanic ridge, the chemosynthesis is going on, which is one of the important aspects of, I said that ecosystem thriving along the sea floor is spreading, where the floor is spreading, and there is several hydrothermal vents are there, white smoker, black smokers are there. Shall I remove? Now we have got the continent, as we have seen that as I said you, I will give you a little bit basic. Some basics that I will provide you, like I said, there are the two ways the magmas are coming upon the Earth's surface. You know that in the deeper mantle, earlier I have discussed as well, presence of radioactive minerals. I said that presence of radioactive mineral. And second one, I said that heat from outer core. Which one I said that? Presence of radioactive mineral and heat from the outer core. That you know that the outer core is highly molten in state and then giving the good amount of heat. And as I said that here the rock get melted. And what is there? If you go into deeper mantle, what will be there? Iron and magnesium will be more, or silica will be more? Iron and magnesium, as I have said that earlier, if I take in a container, and in the container what is there? Silica and iron. And if I shake it, so which one will go down? Iron will go down. And I said that similarly within the Earth's surface, if we will go deeper and deeper, in the Earth's surface we will go deeper and deeper, we will be able to find heavier metals more, means iron and magnesium. In the deeper mantle, the iron and magnesium percentage is very high, yes, and compared to, I said that silica. And what is the melting point of iron? I said that around 800 degrees Celsius and silica around 600 degrees Celsius. It means this rock should melt at 800 degrees Celsius. Yes or not? Silica should also melt, and then iron. But it is not melting. At 800 degrees Celsius. The reason behind, during melting, any molten substances used to expand, but due to high pressure it is not able to expand. Due to high pressure it is not able to expand, and when it is not able to expand, then it will not melt. But by reaching not 1200, 1300, by reaching 1350 degrees Celsius, and it start melting and able to remove the pressure, and thereafter I said that this magma, molten magma in the form of convectional current, they started moving upward. And it takes several years to reach near to the Earth's surface. Earth's surface nahi, better to say near to the Earth's plate. And when it is able to reach near Earth's plate, I said that it is moving away from the source of the heat or energy. Its temperature become 1100. What is the temperature become? 1100 degrees Celsius, 13, 15 and 1100. And then 1100 degrees Celsius magma will be comparatively, what is the name? The contracted form. It will be comparatively contracted form. And this contraction, और यहाँ पर क्या है maximum? Silica. And silica, you know that it is in a comparatively lighter, और यहाँ कौन आ रहा है? Which one is coming? Iron. And the iron at 1100 degrees Celsius, when it started contracting, compared to this, they become heavier in comparison to the surrounding. They become heavier in comparison to the surrounding, and therefore they started what? Convecting downward. So I said that in the deep mantle, kya bana? And this magma is known as, I said that, basaltic magma. What is the temperature? 15 degrees Celsius around. And then what happened? Convection upward near Earth's plate. In some years it able to reach, and its temperature is 1100 degrees Celsius, which is comparatively denser than surrounding, and start convecting downward, and that creates convectional current of